Here's a very fiddly demonstration of a magnetic switch. So there's our very simple paperclip switch there. And what I've done is join a wire from the end of this paperclip back to our buzzer circuit and the end of the other paperclip back to the buzzer circuit. So let's just prove that it works. I'll just tip it over. You can see there's a gap between them, and then I'll just reach in. Okay, we've done that before, so what's new? Well, because the paper clips themselves are made of steel, then they're magnetic. So what we can do is, with the aid of a very small magnet, we can attract the two paper clips together, and then that can act as an actual switch. So what we're trying to show is people have invented ways. So here's the tiny little magnet. People have invented ways of using magnets. Nearly, oh, there we are. Perhaps a stronger magnet would be better. People have invented ways of, oh, there we are, of using magnets to make switches activate. And this is put into practice in all sorts of switches. So when you don't want direct physical contact, you could just bring up a powerful magnet close to the switch. So here's our magnet, and this is what these switches look like when they're opened up. They're actually fitted into a tiny little glass tube. It could be a plastic tube, but this is a glass tube. And inside there, you've got the two little metal contacts like this. And then the magnet doesn't really have to be all that near, so the magnet might only be there. So in a machine, the switch might not have to touch something to make the machine do the next part of its operation. So you can imagine a complicated machine where lots of things are happening at the same time. Reed switches are quite often used to tell you that something is in the right position. So when that magnet is exactly the right distance away, then something else would happen. So a part might come together and be pressed into another part. So machines rely on these sort of reed switches and other similar types of switches.